There is a very beautiful question here that I want to address for the sake of those who are new in engineering, mechanics, statics, and for those who are already reviewing and preparing for their board exam, but they are still confused about this topic. That is the topic on moment. Now, I presented this problem in one of our video lecture, November 2019 CE Board Exam Part 3. So, just look for the discussion of that in this channel. I want to address the question of Aalup channel and Mr. James Claridad. Their question are but the same. Bakit po hindi nasali yung 200 kN? Translating it into English, why the 200 kN moment is not included in the computation? Let us go back a little bit to our solution in that clip. Now, we have here this object being acted upon by these four forces, 50, 80, 60, and 120, with a specified direction, and this moment at 200 kN. Now, we were asked to find the resultant force of this system. So, using mode complex, I presented this as 80 angle 30 plus 50 angle 180 plus 120 angle, this is 360 minus 40, 320 plus 60 angle 270 equals, then convert to polar, it would be R is equal to 147.66 kilonewtons directed in a direction negative 41.14. Meaning, if this is the point where R is acting, it is directed somewhere here at an angle negative, so clockwise angle 41.14 degrees, and R is 147.66 kilonewtons. Again, how do we define a resultant? It is a single force that will produce the same effect as all the other forces combined. So you combine this, and this, that would be the resultant. You get it? So it is very logical to ask, for students to ask, why this 200 is not included in the computation here. Let me explain it. Now, let us say I have here an object, let us say a plate, and acted upon by force F of 100 kilonewtons to the right. It may be at any direction, but for simplicity, let me draw it towards the right. This is point B, point C, which are 1 meter, 2 meters, respectively distance from A. Let me introduce here two terms which are not used in the standard textbooks, but just for the sake of understanding the concept, let me use these two terms. A force has two values, the twist value and the push value. Okay? So, this 100 kilonewton force, it has a push value at A of 100 kilonewton to the right. At B, it also has a push value of 100 kilonewton to the right. At point C, it has a push value of 100 kilonewton to the right. Meaning this force will move the object to the right at 100 kilonewtons. So this will push our object at A, at B, at C 100 kilonewtons to the right. You get it? Now, it has another value which I call the twist value. Now, this force, if you are applying it at A, imagine that there is a pin here where the object can rotate. When you pull this object and you apply the force at A, then the object will not be twisted. It will remain as is and it will just move to the right. Moving to the right is the effect of a push value. But the twist value of this, let me call this TV of F, at A is 0. However, at point B, if the pin will be placed at B and you apply the force here, so your object can rotate at point B. So because of this force, and this is pushing the object to the right and above point B, naturally this object will twist clockwise. It will twist clockwise. So the twist value at point B is going to be the force times the distance, the perpendicular distance. So it is 100 times 1. It is 100 kilonewton times 1 meter, 100 kilonewton meter. While if the pin is placed at C, the twist value of this force F is the force times the distance. So there is another dimension, the distance. You multiply them, that is the twist value. So that is 100 times 2. The twist value of F at C is 200 kilonewton meter. You follow? You get it? Okay. So this force has the same push value at A, at B, and at C, but it has different twist value at A, at B, and C. The farther the point, the bigger the twist value of the force. You get it?
Whoa.
Okay. Now let me introduce another force. Let me introduce a force, let me call it F prime, opposite, exactly opposite, but parallel to F. And this is also 100 kilonewton. Now, what is the push value of F prime at C? 100 kilonewton to the left. The push value of a force, or simply the magnitude of the force at any point, will be the same. So this is 100 kilonewton to the left. At point B, 100 kilonewton to the left. At point A, 100 kilonewton to the left. However, its twist value at C, if you have a pin here and there is no force here, if there is no force here, the twist value of F prime at C, because the pin is at C and the force is at C, it will not, the object will not twist or will not rotate. So the twist value at C of F prime is 0. However, at B, its distance is 1 meter. So its twist value is in this direction clockwise. So that is 100 times 1. This is 100 kilonewton meter clockwise. This one, by the way, they are also clockwise twist value. The twist value of this at point A is 100 times 2. So this is going to be 100 times 2 meters, 200 kilonewton meter clockwise. You follow? So our twist value increases with distance. This twist value that we are calling in this discussion is called in books as moment. Okay? You follow? It's the moment of the force. We normally call this the force. We call this the to the moment of the force. Now, let us elevate now our discussion. Let us say that this one is acted upon both by F and F prime. If we will get the resultant of them, or the resultant force, look here. If you have this object, this is your F, and this is your F prime, both equals 100. What is their resultant? You pull this to the right, you pull this to the left by the same force, walang mararating. So you pull this to the right, you pull this to the left, the resultant is 0. They will not be able to move this. The resultant push value is 0. Right? So that would be, if they are at both at point A, that would be 100 minus 100, 100 minus 100, 100 minus 100, the resultant is 0. You get it? You follow? And the push value, the twist value of this at A is 0. The twist value of them at B, clockwise, counterclockwise, their twist value will be 100 clockwise, 100 counterclockwise. So the resultant twist value is also 0. The resultant twist value at C is 200 clockwise, 200 counterclockwise. So the resultant twist value is 0. So we say that these two forces, the resultant really is 0. Right? You get it? Push value 0, twist value at any point is 0. However, what if the two forces are not exactly opposite? They are not collinear. They are opposite, but they are not collinear. What is the resultant push value of this? 100 minus 100, 100 minus 100, 100 minus 100. The resultant push value at any point is 0. However, let's talk of their twist value. At point A, the twist value of F is 0, but the twist value of F prime is 200. So their resultant twist value at A is 200. At point B, the twist value of F is 100. The twist value of F prime is also 100. So the resultant is 100 plus 100, 200. Right? So at point C, the resultant twist value of F and F prime is 200 plus 0. It's 200. So this pair of forces, opposite in direction, parallel, but not collinear, its resultant push value is 0, but its twist value at any point is 200 kilonewton meter. You follow? Or its resultant moment is 200 kilonewton meter. So I can say that this 200 kilonewton meter is equivalent to two forces opposite but not collinear. There is an offset called the moment arm. So acting on that object, it may be a pair of 100 kilonewton opposite in any opposite direction, and the distance is 2 meters, or 200 kilonewton in any opposite direction, and the distance is 1 meter. So as to fit in our discussion, they are 1 meter apart. This 200 kilonewton meter may simply be taken as two opposite forces, 100, 2 meters apart. Right? So that it is 100 times 2, 200 kilonewton meter twist. So that is the twist value. This will be the equivalent. You get it? You follow? A pure twisting force may be taken as opposite forces we call couple, so that their resultant push value is 0, but the twist value is equal to the force times their distance. So when you draw this, find the resultant of the force, you add here the push value. The push value of this and the push value of this will be 0 because 100 angle 0 plus 100 angle 180, that will be equivalent to 0. Or you may add here 100 angle 0 plus 100 angle 180 degrees. You follow? And the resultant will be this one. You get it? So, this, or the equivalent of this is the moment of 200 kilonewton will have a resultant push value of 147.66 angle minus 41.14 degrees. The question is, where will the moment enter when we compute the twist value of the forces? You get it? Remember, a force has two values. The push value, called the magnitude. The twist value, called the moment. Okay? Let me add another problem for clearer understanding. What about this one? What is the moment or the twist value of all these forces about point O? Okay, let's do it. The moment of 120 or the twist value of 120 about O is 0 because it passes through O. Imagine there is a pin at O. You apply 120. The 120 cannot twist the object because it is acting on the pin. Right? So, let me call the twist value as the moment. Moment about O. The moment about O of all the forces is the sum of the moments or twist value of all forces about O. The moment of this is 0, while this one is minus 50 times 6 meters. Minus, I will put negative sign for counterclockwise. So, minus 50 times 6. So, I'm done with this. I'm done with this. The 60 kilonewton will have a clockwise moment. So, plus 60 times its perpendicular distance is 448 meters. Now, our problem is this 80 kilonewtons. It is inclined. So, the solution is split this into two components. One is the horizontal component. The other is the vertical component. This horizontal component is adjacent to 30. So, this must be 80 cosine 30 degrees. This one is not adjacent to 30 degrees. So, this is sine. So, this is 80 sine of 30 degrees. So, I will deal with 80 kilonewton in terms of the twist value of this vertical and horizontal about 0 or moment instead of twist value. So, this vertical will produce or will rotate the object in the counterclockwise direction. So, minus that vertical force 80 sine of 30 degrees times its moment arm, this is vertical, its perpendicular distance from O is horizontal, this one. This is the line of action of the vertical, the horizontal distance is 8 meters. So this is times 8. Now, this horizontal component, if there is a pin at O, will rotate the object to the right or clockwise, so positive. So, it would be plus that magnitude 80 cosine 30 times the moment arm. This is horizontal, this one. the moment arm will be vertical. So the line of action of AT is this. The vertical distance from O is 6 meters. So times 6. So we are done with this. Moment is 0. This, and this. There is one more. The moment of this 100 kilonewton, 2 meters apart about O. What is that moment? What is the twist value of this about O? 200, right? Okay? Right? Its original value is the twist value 200 kilonewton meter clockwise. Let us compute it again, huh? For example, we consider the two separately. The moment of this 100 about O is 100 times the moment arm vertical. 4 meters plus 1.5. So that would be 100 times 5. And that will produce clockwise rotation about O. This 100 will produce counterclockwise rotation about O. So that would be minus 100 times the moment arm. This is 4 meters, this is 1 meter, so this is 3 meters. 100 times 3. You calculate it, it would be 100 times 5. 500 minus 300. 200 positive. So this pair of forces couple can be conversely replaced by that twisting force 200 kilonewton meter or merely a pure twist value. You get it? So therefore this will just be plus 200. Your 200 kilonewton meter is not neglected. Okay? It is considered when we are computing that twist value or moment. You get it? But when we are computing the push value or resultant force, then we don't consider it. You get it? So, therefore, computing the moment of all the forces about O, this would be, so you will get here positive 475.69 kilonewton meter. Do you understand? Okay. Now, sir, please explain further. Let us say I have another problem here. Find the distance of the resultant from O, or find the perpendicular distance of this R from point O. Yes, we know that it is 147.66. Yes, we know it is at an angle of 41.14 degrees clockwise from the horizontal. But where it is acting on this plate? Let me return it to its original figure. There is a 200 kilonewton meter purely twisting force here. Okay? Or pure twist value here. So, let us assume that your R is here. This is your R, which is 147.66 at an angle of 41.14 degrees with a horizontal. If this is 41.14, this is also 41.14 degrees, right? Now, its perpendicular distance from point O, this one, this is your Z. Right? Okay. Now, according to our definition, what is a resultant? It is a single force that will produce the same effect as all the forces combined together. So you combine this 50, this 120, this 60, this 80 kilonewton together with this 200 kilonewton meter, its effect. When we say effect, its push value and its twist value about any point will be the same. You get it? You follow? So, the push value of this 1, 2, 3, 4, 5, the push value about O is this one, 147.66. The push value of a force is regardless of the location of the point. But the twist value depends on its location, right? So the push value of this, and this is equal to 147.66. But its twist value will be dependent on its position. So we say that the twist value or moment of the resultant about O is equal to the moment of forces and couple, which is the twist force 200 kN about point O. What is the moment of R about O? The moment of the single force equivalent to all of them is R times Z. So that is equal to 147.66 times Z. And the moment of all these forces about O is 475.69, giving us RZ equals 3.22 meters. You follow? You get it? So if you are interested with the x-intercept, this one, since this is a right angle, all you need to do is try taking sine of theta. Sine of 41.14 equals Z over this x-intercept. Okay? So that will enable you to solve the x-intercept. I repeat, the sine of 41.14 degrees equals Z over the x-intercept. You just substitute the value of Z, 3.22, you'll be able to get the x-intercept. You follow? I hope I answered the question of 𝘾𝙊𝙆 and James Claridad. Okay? So thank you for the question, and I believe that a lot of students learned from your questions. So please share our channel, and please don't forget to visit our page. The links are in the comments section below or description below. Please visit it. You will definitely be interested to enroll in our subject mastery courses, or if you are reviewing for your board exam for civil engineering, you will find it very helpful to enroll in our review program. So